Myself, Mr. Prasad Kundu, Assistant Professor, Department of Mechanical Engineering, Mallabhum Institute of Technology, Bishnupur, Bankura. I am going to introduce about Francis turbine. Francis turbine is a hydraulic machine. Hydraulic machine are those machines which convert hydraulic energy into mechanical energy or mechanical energy to hydraulic energy. In case of pump, mechanical energy is transferred to hydraulic energy. In case of turbine, hydraulic turbines convert hydraulic energy of water into mechanical energy, which is further converted into electrical energy. This energy obtained is known as hydroelectric power, which is one of the cheapest form of energy generation. Hydraulic turbines consist of Pelton wheel, Francis turbine, and Kaplan turbine. All the hydraulic turbines are broadly classified impulse and reaction turbine. In case of impulse turbine, hydraulic energy first transferred to kinetic energy and then mechanical energy. But in case of reaction turbine, hydraulic energy transferred to kinetic energy as well as pressure energy. And this kinetic energy and pressure energy transferred to mechanical energy. And this mechanical energy is used to rotate a shaft. In case of impulse turbine, working principle is fully impulsive. But in case of reaction turbine, the working principle impulse as well as reaction. In case of impulse turbine, wheel revolves in open air. But in case of reaction turbine, wheel submerge in water. In case of impulse turbine, pressure difference. Inlet pressure and the outlet pressure will be same, no changes. But in case of reaction turbine, inlet pressure will be high and the outlet pressure will be low. Pressure will changes. In case of impulse turbine, casing has not to perform any hydraulic action, only prevents flushing of water. But in case of reaction turbine, casing has to perform hydraulic function. In case of impulse turbine, inlet pressure denoting by P1 and outlet pressure denoting by P2 will be same and it will be the atmospheric pressure. And V1 is the absolute velocity at inlet and V2 is the absolute velocity at the outlet. Inlet velocity V1 will be very, very greater than V2 in case of impulse turbine. Very good example of the impulse turbine is the Pelton wheel, Targo, Banki, etc. In case of reaction turbine, inlet pressure will be high and the outlet pressure will be low. Generally, the outlet pressure will be vacuum pressure, below atmospheric pressure, and the velocity, absolute velocity V1 is high, then that the exit velocity V2. Very good example of the Francis Kaplan propeller turbine is a good example of the reaction turbine. In impulse turbine, high head are utilized, but in case of reaction turbine, low head will be utilized. Energy takes place in case of impulse turbine due to impulsive action, but in case of reaction turbine, energy transfer takes place due to reaction between flowing water and vane surface and impulsive action. In case of impulse turbine, casing need not to be airtight, but in case of reaction turbine, casing must be airtight. In case of impulse turbine, as the pressure not fall below atmosphere, cavitation will not happening. But in case of reaction turbine, as the pressure fall below the atmospheric, low pressure, cavitation may occur. For same head and power size, turbine size will be very large in case of impulse turbine, and in case of reaction turbine, relatively small. In impulse turbine, generally simple in construction, but poor efficiency. but in case of reaction turbine, construction will be complicated and relatively high efficiency. Francis turbine is the first hydraulic turbine with radial inflow. It was designed by an American scientist, James Francis. If the water flows radially through the runner from outwards to inwards, then it is known as an inward radial flow turbine. Francis turbine is a example of a inward radial flow turbine. Francis turbine is a reaction turbine as the energy available at the inlet of the turbine is a combination of kinetic and pressure energy. So here different runner is showing. First is the Francis runner, the radial blade reaction turbine. Second, Kaplan runner. This is the axial blade Kaplan turbine, reaction turbine, axial flow reaction turbine. And the Pelton runner, this is the tangential flow, tangential blade, and bracket ring also of the Pelton wheel is shown. So different component of the Francis turbine is here shown. Water coming from the penstock enter in the scroll casing. When the water flow in the scroll casing, the pressure is decreasing and the velocity increase. From the scroll casing, water first entered in the steering allow the water to enter in the guide vane. The guide vane allow water to enter in the runner. So the main function of the guide vane, entering of the water is very smoothly and without shock. It controls the flow of water according to the load condition. That means the guide vanes are connected to the governor. After working on the runner, the water will be discharged to the tail race by the draft tube. Draft tube also a function, hydraulic function is there. Pressure in the exit of the turbine will be decreased. So another is the laboratory setup of a Francis turbine. The guide vanes, red one is the runner and yellow is the guide vane. So guide vane mechanism, the runner is shown in another slide. Another example, and it is the laboratory setup of a Francis turbine. So Francis turbine is showing all the component, scroll casing, shaft, guide vane, runner, draft tube, etc. So the radial alignment of the Francis turbine is shown. The inner radius is the runner surrounded by a series of guide vane. Then the guide vane are surrounded by a series of stray vane. Different diameter also is shown. This is the radial view of a Francis turbine. So main parts of a Francis turbine. First is the casing. The runner is completely enclosed in an airtight spiral casing. The casing and runner are always full of water. Guide mechanism. It consists of a stationary circular wheel on which stationary guide vanes are fixed. The guide vane allow the water to strike the vane of the runner without shock at inlet. Runner. It is a circular wheel on which a series of curved radial guide vanes are fixed. Draft tube. It is used to discharge water from the outlet to the runner to the tail race. Thank you.